You were once part of a star. This audiobook invites you to discover a truth as astonishing as it is real. The atoms in your body were forged in the hearts of suns that exploded billions of years ago. Every breath, every heartbeat carries the trace of distant supernovas. How did that stardust travel? What cosmic paths did it take to form oceans, mountains, and ultimately you? A story of death, transformation, and rebirth that connects us to the deepest parts of the universe. Stardust, though small and invisible to the naked eye, is the result of colossal processes occurring in space. What if I told you that every carbon atom in your body, every oxygen molecule in the air comes from the explosions of stars that lived and died millions of years ago? This concept may seem astonishing, but it is the truth that connects us all to the cosmos in an intimate and profound way. Throughout the history of the universe, stars have been the great architects of matter. From their formation in clouds of gas and dust to their eventual death, each stage of their life contributes to the creation of stardust. I invite you to imagine a star as a cosmic factory that, through a magical process called nuclear fusion, transforms simple elements into the most complex components of the universe. But what happens to those elements once the star exhausts its energy? Supernovas, those titanic explosions that mark the end of a star's life, are some of the most impressive events in the cosmos. In those moments of cataclysm, enormous amounts of energy and matter are released into space. It is at this stage that stardust is scattered, enriching the interstellar medium and laying the groundwork for new generations of stars and planets. But what happens to that dust afterward? How does it become something tangible and ultimately life? The cycle of stardust is an endless journey that connects dying stars with the creation of new celestial structures. This cycle allows dust to travel through space, integrating into new stellar formations and planetary systems. Have you ever wondered how the planets that orbit around a star are formed? It is thanks to this dust, which clumps together and compacts, giving rise to worlds like ours. The chemistry of stardust is another crucial part of this cosmic narrative. Composed of essential elements like carbon, oxygen, and nitrogen, this dust is not only important for the formation of stars and planets, but also plays a key role in creating complex molecules necessary for life. Without stardust, Earth would not be the fertile place we know today. But what is the connection between dust and life itself? On Earth, stardust has influenced our evolution since its beginnings. Every grain of dust that falls on our planet is a reminder that life is not an isolated phenomenon, but the result of a long series of cosmic events. The history of our planet is intrinsically linked to the history of the universe, and when we look up at the sky, we are seeing the echo of the stars that have left their mark in the dust that surrounds us. The relationship between stardust and terrestrial biology is astonishing. Elements like carbon and oxygen, fundamental to life, are the legacy of stars that have shone in the past. When you think about the air you breathe or the atoms in your cells, it's as if you can feel the pulse of the universe within you. This connection reminds us that we are part of something much larger, a cosmic tapestry that unites us with the stars. Stardust also plays a role in the search for life on other planets. Scientists are beginning to understand that the conditions necessary for life may be found in places that once seemed inhospitable. Could stardust be the key to unraveling the existence of life beyond Earth? Astrobiology delves into this fascinating question, investigating how the elements that formed our planet may also give life to other worlds. Observing stardust is a challenge for astronomers. They use telescopes and space probes to study this elusive material. These instruments allow them to capture the light that passes through the dust, thereby obtaining information about its composition and distribution in space. Can you imagine being able to see clearly what is thousands of light years away? Simply by observing how light behaves as it passes through dust. The story of stardust is ultimately the story of the universe itself, from its origin in the Big Bang to its dispersion in space after the death of stars. Dust has been a key player in the evolution of the cosmos. It helps us understand how the structure of the universe has formed and how it has changed over time. Reflecting on this leads us to question our place in the cosmos and the legacy we will leave behind. Stardust has also found its way into human culture. Throughout history, different civilizations have interpreted dust and stars in unique ways, weaving mythologies and philosophies that reflect our connection to the universe. How have these beliefs influenced our understanding of the cosmos and our place within it? As we move into the future, stardust will continue to be a subject of research and wonder. Questions about its origin, its role in the creation of new stars and planets, and its impact on life on Earth will continue to intrigue scientists and philosophers alike. Stardust is not just an element of space, it is a constant reminder that everything we know has been shaped by cosmic forces. And in the end, our very existence can be seen as a fleeting spark of dust in a vast, ever-expanding universe. Stardust is a fascinating concept that intimately connects us with the universe, but what exactly is stardust? In simple terms, it can be described as tiny particles floating in space composed of elements like carbon, silicon, oxygen, and heavy metals. These tiny specks are the result of extraordinary processes that occur in the life cycle of stars. To understand its origin, it is crucial to know that stars are like cosmic factories. During their lifetime, they fuse elements in their core, creating new atoms that are then released into space. Can you imagine a star as a chef preparing a stellar recipe? Each star cooks its own dish. And when it reaches the end of its cycle, it shares those ingredients with the universe. What happens when a star reaches its end? This is where the story becomes even more amazing. When a star exhausts its fuel, it can explode in a supernova, an event so powerful that it can shine brighter than an entire galaxy for a brief period. This explosion is not only spectacular but also fundamental to the creation of stardust. In the moment of its death, the star throws into space all those elements it had forged throughout its life, scattering them into a vast environment. It's as if it were tossing a handful of cosmic confetti, full of matter that will give rise to new stars and planets. Now, why is this dust so important? Once it is dispersed, stardust becomes part of the molecular cloud, a place where matter can group together and give rise to new stars. Imagine a large nebula, a stellar birthplace where dust and gas come together, cool down, and begin to compact. Just like when you knead flour and water to make bread, this dust becomes the building blocks of new stars and planets. The composition of stardust is equally intriguing. It contains elements that are essential for life as we know it. Did you know that carbon, oxygen, and other elements that make up our bodies ultimately come from this dust? It is a continuous cycle in which stardust plays a crucial role in the creation of complex molecules that are the basis of life. If you think about it, every time you breathe, you are inhaling stellar history. Remnants of ancient stars that have traveled millions of light years to reach you. Stardust is not only important for the formation of new planetary systems, but also influences the chemistry of those worlds. When a new star is born, the planets that form around it do so from this very dust. So, in a sense, we are all stardust. From the moment a star explodes to the formation of a new planet, dust is the thread that connects every part of this immense cosmic tapestry. Have you ever wondered how stardust affects the climate of our planet? Although it may seem surprising, scientists have discovered that dust from supernovae and other sources can influence cloud formation and precipitation. It is a reminder that we are interconnected with the cosmos in ways we never imagined. Every particle of dust that falls on Earth has a story to tell, a journey that began in the heart of a distant star. As we look to the future, research on stardust continues to reveal secrets about its nature and its role in the evolution of the universe. Scientists are using telescopes and space probes to study these particles in more detail, allowing us to better understand how they form and how they interact with their environment. It is a field of study that is constantly evolving, with new theories and discoveries emerging all the time. Stardust is undoubtedly a fundamental component that helps us understand not only the formation of stars and planets, but also our own existence. Every time we look at the starry sky, we can remember that those bright lights are more than just simple points in the firmament. They are the traces of ancient stars that have left their mark on the universe. Therefore, when contemplating the sky, we are not only looking up, but also inward, toward our own connection with the cosmos. This stardust, although often invisible to the naked eye, is present everywhere, waiting to be discovered. So the next time you look up at the stars, remember that every twinkle of light is a reminder that we are made of the same material that composes the universe. In this vast cosmic stage, stardust is the thread that weaves our story, a story that continues to be written in every corner of the universe. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The stars, those magnificent lights that shine in the night sky, have a surprising and complex life. But did you know that just like us, stars are born, live, and die? Their story is an extraordinary journey that spans millions of years and, after each cycle, generates fundamental elements for the matter that makes up the universe. How does a star become what it is? What stages does it go through in its existence? From the moment a star begins to form, it is destined to follow a fascinating path. It all starts in a nebula, a huge cloud of gas and dust. This is where particles meet, clump together, and heat up. As gravity does its work, the center of this cloud compresses, creating what we know as a protostar. But what happens next? This protostar begins to shine as it reaches extreme temperatures. What was once just a collection of matter becomes a star in full formation. A star's life is not monotonic, it is full of changes. Depending on its mass, it can become a dwarf star like our Sun, or a massive star that will eventually become a supernova. Smaller stars at the end of their lives expand and become red giants before shedding their outer layers into space. But what happens to the core? It collapses, giving rise to a white dwarf. In the case of massive stars, the end is even more dramatic. The explosion of a supernova not only marks its death, but also acts as a generator of stardust. It is fascinating to think that every time a star explodes, it releases a colossal amount of energy and matter into space. This dust, the result of the combustion of elements in the heart of the star, is extremely important. Why? Because every grain of stardust contains atoms that will be part of future stars, planets, and even life itself. Thus, the death of a star gives rise to creation. The life cycle of a star does not end with its death. In fact, this is where a new chapter begins. The stardust generated in the explosion of a supernova disperses throughout the universe, forming new nebulae that in turn can give rise to new stars. Can you imagine an endless cycle where matter transforms and is reborn over and over again? This process is fundamental to the evolution of the universe and the creation of new generations of celestial bodies. But how is it determined what type of star will form from a nebula? This depends on the amount of matter present in the original cloud. More massive stars evolve quickly and have shorter lives, while smaller ones, like dwarfs, can shine for billions of years. Each star has its own destiny, and each of those destinies is intertwined in this vast cosmic web. As stars are born and die, stardust becomes an essential component of the cosmos. This dust is not only beautiful, but also the foundation of everything we know. Elements like carbon and oxygen, fundamental to life, are created inside stars. When a star explodes, those elements are released into space, where they can be captured by new stellar formations. It is amazing to think that the dust we see on Earth, the same that accumulates in our homes, has a history that dates back to the stars. Each particle of this dust has traveled through time and space and has been part of a cosmic cycle that connects everything we are. But how do we know this cycle is real? Through astronomical observations, scientists have been able to track this dust and its evolution over billions of years. Stars, despite their grandeur, are vulnerable. Their lives are marked by changes and transformations, and in the end they must surrender to their fate. However, their legacy endures in stardust, which not only forms new stars but also contributes to the creation of planets and ultimately life. This life cycle of a star is a reminder that death can be the beginning of something new. The story of the stars is, in many ways, a reflection of our own. Just as they transform and evolve, so do we. We connect with the cosmos through the elements we share, and that connection feels deeper when we understand that we are part of a greater cycle. In every corner of our being, we carry a fragment of the universe, an echo of the stars that once shone brightly in the sky. In the end, the life of a star is an epic journey, one that invites us to contemplate our place in the vast universe. Each star is a teacher that teaches us about transformation, connection, and the continuity of life. Although its existence may be fleeting, its impact resonates throughout eternity, reminding us that we are all made of stardust. Supernovae are amazing and dramatic events in the life cycle of a star. But what exactly is a supernova, and why is it so crucial for the existence of stardust? To understand this, we must first visualize the final fate of stars. When a massive star has exhausted its nuclear fuel, its core collapses and triggers a titanic explosion. This explosion is not only an impressive spectacle in the cosmos, but it is also the main source of stardust. Imagine you are at a rock concert. The band is playing their last song, and the energy in the air is palpable. Suddenly, the singer throws his guitar into the air at a climactic moment, and the guitar flies through the air, disintegrating as it falls. This is how a supernova disperses its outer layers filled with chemical elements into the vastness of space. But what about those elements? They are much more than simple particles. They are the building blocks of everything we know, from planets to living beings. Supernovae not only create dust, but they also enrich the interstellar medium with heavy elements like carbon, oxygen, and iron. Have you ever wondered where the elements that make up our bodies come from? The answer lies in the life cycle of stars, and in particular, in supernovae. Every time a star explodes, it is sowing the space with the necessary ingredients for life. The stardust generated by these explosions travels through the cosmos, forming clouds of gas and dust that eventually condense to form new stars and planets. This leads us to a fascinating question: is stardust a cosmic fertilizer? In a way, yes. It acts like the fertilizer that nourishes the next generation of celestial bodies. Without supernovae, the universe would be a much emptier and less diverse place. The process of stardust formation after a supernova is truly impressive. When the star explodes, extreme temperatures and pressures are generated. This causes atoms to combine in new ways, forming dust particles that can be as small as a grain of sand or as large as a small moon. Isn't it incredible to think that the same elements that make up your body were once part of a star that exploded in space? But not all supernovae are the same. There are different types, each with its own characteristics and contributions to stardust. For example, Type Ia supernovae result from a white dwarf star accumulating material from a companion star until it reaches a critical limit, triggering an explosion. On the other hand, Type II supernovae occur when a massive star exhausts its fuel. Can you imagine the difference in the stardust generated by these two types of explosions? The dispersion of stardust is not an isolated event. It is a continuous process that contributes to the life cycle of the universe. As dust disperses, it interacts with other clouds of gas and dust, forming new generations of stars. This is how the universe is constantly recycling itself, an endless cycle of creation and destruction. Isn't it amazing to think that every star we see in the sky could be the result of a supernova that occurred thousands or millions of years ago? Stardust also plays an important role in the formation of galaxies. By clustering and condensing, dust and gas can form new stars, which in turn can form planetary systems. And here we encounter another intriguing question. Are supernovae the architects of the universe? In a sense, yes. Without their explosive contribution, our universe would be a very different place. Moreover, stardust plays a role in cooling and forming complex molecules in space. When dust clusters, it can attract more material and form larger structures. These structures can be the home of future stars and planets, but they can also harbor the ingredients for life itself. So the question is stardust the seed of life in the universe? Astronomers have developed various techniques to study supernovae and the dust they generate, from telescopes observing in different wavelengths to space probes traveling through the solar system. Scientists are constantly searching for new ways to understand how these explosions impact the universe. Can you imagine a future where we can predict when a supernova will occur and what effect it will have on our own solar system? In the quest for answers, scientists have discovered that stardust is not only important for the formation of new stars and planets, but it can also influence the climate and chemistry of planetary atmospheres. So the next time you look up at the starry sky, remember that those stars are much more than just bright points. They are factories of stardust that have played a fundamental role in the creation of our universe as we know it. The journey of stardust from its creation in a supernova to its eventual incorporation into new stars and planets is a long and fascinating process. But the most interesting thing is that this cycle never stops. Every supernova is a new opportunity for stardust to give life to something new. How will this change our understanding of the universe in the future? Only time will tell, but what is certain is that supernovae are an essential part of our cosmic history. So the next time you stop to gaze at the stars, remember that each of those lights in the sky has a story to tell, a story that begins in the heart of a star and ends in the creation of stardust, which in turn gives life to new stars, planets, and perhaps one day to ourselves. Stardust, that material floating in the vast ocean of space, has a fascinating story to tell. But how does this dust move through the universe? What journey does it take from its birth to becoming part of new stellar systems? The cycle of dust in space is an extraordinary journey that connects the life and death of stars, and through this journey the universe is constantly reconfiguring itself. At the beginning, stardust is the result of an incredible process. The death of a star. When a star exhausts its fuel and reaches the end of its life, a monumental explosion known as a supernova occurs. This event is not only dazzling but also fundamental to the creation of stardust. But what happens after that brilliant explosion? This is where a fascinating cycle of creation and transformation begins. The dust particles resulting from a supernova are like seeds floating in space. These tiny particles can travel enormous distances, carrying with them the chemical elements that once formed part of the star. It is astonishing to think that those atoms of carbon, oxygen, and other elements that make up stardust are the same ones that can give rise to new stars and planets. But how does this dust become incorporated into the formation of new cosmic structures? Over time, stardust gathers into dense clouds. These clouds, called nebulae, are the places where the magic really begins. In this environment, gravity starts to play a crucial role. The dust particles attract each other, forming increasingly larger conglomerates. It's as if they are in a cosmic dance, united by the force of gravity, forming what will eventually become new stars and planets. But what happens to the dust that does not become part of a new star? Some of these dust grains continue their journey through the universe, dispersing and enriching the interstellar medium. They act as cosmic fertilizers, providing the essential ingredients for life elsewhere in the universe. It's as if stardust is on a mission, spreading vital elements along its journey, ensuring that in some corner of the cosmos, new forms of life can emerge. As newly formed stars shine in the sky, they also begin to influence the dust around them. The radiation and stellar winds from these young stars push and shape the dust, forming new structures and gas clouds. Who could imagine that the dust cycle is not only limited to the creation of stars, but is also in constant interaction with the surrounding environment? Over time, this dust can become part of a new planetary system. The rings of dust surrounding a young star become the building blocks of planets. It's a process that can take millions of years, but every dust particle is contributing to the creation of new worlds. The story of Stardust is, in this sense, a story of continuous transformation. But could it be that Stardust also has an impact on us, here on Earth? As planets form, the story of Stardust intertwines with the history of each planet. The elements that make up the dust are essential for the formation of life as we know it. Without that dust, we wouldn't have the carbon that forms the basis of our biological molecules, nor the oxygen we breathe. It's almost poetic to think that everything we are and everything around us has a common origin in the stars. The dust cycle doesn't stop here. When planets form, they can also experience their own eruptions and catastrophes, releasing dust back into space. This dust in its journey can be captured by other stars or even by other planets, perpetuating the cycle. It's an endless cycle that has been occurring for billions of years, reminding us that the universe is a constantly changing place. The conditions of space, with its extreme temperatures and near absolute vacuum, also play a role in how stardust transforms. Cosmic radiation can ionize the dust particles, changing their composition and properties. This process can cause the dust to transform into something completely different, which in turn influences future stellar systems. The story of Stardust is a testament to the cyclical nature of the universe. From its birth in the explosions of supernovae to its eventual incorporation into new stars and planets, Stardust is a reminder that the death of a star is not the end, but rather a new beginning. Each dust particle is a thread that connects the past, present and future of the cosmos. So the next time you look at the stars, remember that the dust floating in space is on an epic journey, a journey that not only shapes the universe but also connects us all. Each one of us, with the stories of the stars that shine in the night sky. It's an endless cycle of life, death, and rebirth that invites us to explore and better understand our place in the vast universe. What makes Stardust so fascinating? This question takes us to a world where chemistry becomes cosmic poetry. Stardust is a collection of tiny particles floating in the vast ocean of space, but what is really inside these little specks? The answer is complex and rich in nuances. First, it is important to know that stardust is not just residue, it is the legacy of stars. When a star reaches the end of its life, it explodes in a titanic spectacle known as a supernova. This event not only disperses energy throughout the universe, but also ejects a mixture of elements into space. Thus, what we consider stardust is actually a combination of carbon, oxygen, silicon, and other elements that are the building blocks of the matter we know. Have you ever wondered how these elements become something more? When stardust gathers, it can begin to form new stars and planets. But before that, the dust must undergo a series of chemical transformations. From hydrogen, the simplest element, to more complex elements like iron or gold, dust is a cosmic traveler that has been on a journey of millions of years. The conditions in space are extreme. Cosmic radiation, freezing temperatures, and gravitational forces play a crucial role in how stardust behaves. For example, in molecular clouds where dust accumulates, temperatures are so low that atoms can bond and form molecules. This process is fundamental for the creation of compounds that will eventually become the basis of life. But what kind of molecules are formed from this dust? Often, complex organic compounds, such as amino acids, are created, which are essential for life as we know it. In this sense, stardust plays a crucial role in prebiotic chemistry, the process that led to the emergence of life on Earth. Without dust, the history of our planet could have been completely different. Now, let's talk about variety. Stardust is not homogeneous. There are different types of dust grains, each with its own chemical composition. Some are rich in carbon, while others may contain silicates or even heavy metals. This diversity not only enriches space, but also provides the necessary tools for the formation of planetary systems. Did you know that stardust can also influence the temperature of molecular clouds? The way dust absorbs and scatters light has a direct impact on the temperature of the environment. This phenomenon can determine whether a cloud collapses to form new stars or remains as an inert cloud. Thus, stardust acts as a regulator in the life cycle of stars. The interaction between dust and starlight is fascinating. When light from a star passes through a dust cloud, it can be absorbed or scattered. This process can reveal the chemical composition of the dust, allowing astronomers to study its nature without having to travel to the location. In this way, stardust becomes an open book that tells the story of its surroundings. Following the thread of chemistry, the way stardust behaves in different environments is also intriguing. In some regions of space, dust can form dense clumps that act as incubators for new stars. In others, it can disperse, expanding its reach and enriching the interstellar medium with new elements. Stardust also becomes an integral part of the matter that makes up planets. When planetary systems form, dust clumps together and compacts, creating larger bodies that eventually become planets. Therefore, every time we look around, we are surrounded by stardust, even in the most everyday objects. But what about its impact on life itself? The elements that make up stardust are essential for life. Carbon, oxygen, nitrogen. All these elements are part of our DNA and the molecules that compose every living organism. Without stardust, there would be no organic matter. And without organic matter, there would be no life. This leads us to a profound reflection. Every time we breathe, every time we touch something, we are in contact with the dust of stars. In the context of astrobiology, the study of stardust becomes even more vital. Research suggests that other planets and moons in our solar system, and even beyond, may contain stardust that is key to the search for extraterrestrial life. The composition of that dust could provide clues about whether there are suitable conditions for life, making this dust a target for exploration. Finally, stardust is, in a way, a symbol of connection. It reminds us that we are part of a much larger cycle. What we today consider cosmic junk is in fact the material that composes us and has shaped our world. Every time we look at the night sky, we are not just observing stars. We are looking at our cosmic ancestors and remembering that, in a sense, we are all stardust. Stellar dust is one of those cosmic secrets that often goes unnoticed. But did you know that this dust plays a crucial role in the formation of planetary systems? As the dust clumps together and condenses, it gives rise to a cosmic dance that culminates in the creation of new worlds. This process is comparable to how the ingredients of a recipe combine to create a delicious dish. Without stellar dust, we would have no planets, no stars, and not even life. When a star reaches the end of its life cycle, it becomes a kind of dying star. During this phase, enormous amounts of dust and gas are released into space. This dust is not just simple residue. It is the essential material that will become something new and exciting. Think of it as the bricks of a building. Without these bricks, you couldn't build anything. Thus, stellar dust becomes the fundamental ingredient for the creation of new stars and planets. Have you ever wondered how those disks of gas and dust that you see in space images are formed? These disks are like the rings of a planet, but instead of being merely decorative, they are the place where the magic of creation happens. Gravity plays a fundamental role here. Just as a magnet attracts metallic objects, gravity pulls in dust and gas, forming a rotating disk. Over time, this disk clumps together and forms planets, moons, and other celestial bodies. It is a process that can take millions of years, but every second counts. The stellar dust in these disks is not homogeneous. It has a wide variety of sizes and compositions, and each particle tells its own story. Some particles are so small that they might go unnoticed, while others are large and dense. This diverse set of elements is crucial, as each contributes different properties to the new planetary systems that are forming. Imagine a fruit salad. Each fruit adds its flavor and texture, creating a delicious and nutritious dish. When we talk about the formation of planetary systems, we cannot overlook the importance of time. The creation of a new world does not happen overnight. In reality, it can take hundreds of thousands of years. But why is it so slow? The answer lies in how the dust particles interact with each other. They collide, group together, and sometimes break apart. This process of bumping and sticking is a cosmic dance that takes its time. As the dust begins to clump together, it starts to form cores that will attract more material. This is a critical moment in the formation of a new planet. It's like building a snowman. First, you need a small clump of snow that attracts more snow around it until you get something big and solid. When these cores grow large enough, they become what we call planetesimals, which are the building blocks of planets. Once these planetesimals have formed, gravitational attraction becomes even stronger. They are not only attracting more dust and gas, but also other planetesimals. This process resembles a snowball getting larger as it rolls down a hill. The bigger it gets, the more material it attracts, and thus a planet is formed. But not all planetesimals will end up being planets. Some will remain along the way, becoming asteroids or comets that will follow their own journey. The formation of a planetary system is not a uniform process. One planet may form quickly, while another may take millions of years. This is because the conditions in the dust disk are not always the same. Sometimes there is more material available and other times less. Additionally, planets can influence each other, altering their orbits and trajectories. It's a great cosmic game of dominoes where each piece has to fit perfectly for the system to work, and that brings us to Earth. Our own planet is the result of this complex story of stellar dust. Every corner of our world, from the mountains to the oceans, is imbued with the history of that dust. Without it, we would not exist. So every time you look up at the sky, think about stellar dust. That small and seemingly insignificant material has been the architect of everything we know. The connection between stellar dust and life does not stop at the formation of planets. Once these celestial bodies are established, dust also plays a role in the conditions necessary for life. The elements that form from this dust become the building blocks of the organic molecules that are essential for life. Carbon, oxygen, nitrogen, all of these elements have their origins in stellar dust. So, in summary, the story of planetary system formation is a fascinating narrative about how stellar dust, in its many forms, becomes the founder of worlds. From the creation of planets to the formation of the conditions necessary for life, stellar dust is the invisible thread that connects the cosmos with what we know as home. The next time you look up at the starry sky, remember that those stars and the dust surrounding them are part of our story, and in a way, we are stardust too. Stardust, that mysterious substance floating in the vast universe, has played a crucial role in the formation of our home, Earth. But how is it possible that what seems to be just a residue from space is so fundamental to our existence? In this journey through the cosmos, we will discover the intricate connection between stardust and the history of our planet. To begin, let's think of Earth as a huge ball of ingredients. Just as a chef needs the right elements to create a delicious dish, our planet also required a specific set of materials to form. Stardust, like a cosmic chef, provided those essential ingredients. But where does this magical dust come from? Its origin dates back to the death of stars. Stars, those gigantic spheres of gas in the sky, live fascinating lives. When a star runs out of fuel, it explodes in a cataclysmic event known as a supernova. This spectacle is not only impressive, but it is also the moment when chemical elements are released into space. In this way, stardust is scattered, enriching the interstellar medium with materials that will later form new stars, planets, and eventually life. To better understand this relationship, it is essential to consider how our solar system was formed. About 4.5 billion years ago, a cloud of gas and stardust began to collapse under its own gravity. This process, driven by the forces of nature, led to the creation of the Sun and the planets that surround it. Thus, through a process that seems straight out of a science fiction movie, stardust became the raw material of our world. So, what exactly are the components of that stardust? It is composed of a mix of elements including carbon, oxygen, nitrogen, and many others. These elements are like the letters of the cosmic alphabet, combining to form the molecules that are essential for life. Without this dust, we would have no water, no air, and ultimately, no life. But the journey of stardust doesn't end once it enters the formation of a planet. As Earth began to form, stardust continued to influence its evolution. Collisions of particles and dust in space contributed to the creation of oceans and the atmosphere. In other words, stardust was the architect that designed the conditions necessary for life to arise. Now, it is fascinating to think that every time we breathe, we inhale atoms that have traveled through space for billions of years. Each inhalation is connected to a cosmic story, a journey that began in the heart of a star. It's as if every molecule of oxygen we breathe carries with it a piece of the universe's history. And what about life itself? The elements that make up our bodies, such as carbon and oxygen, have their origins in stardust. So in a sense, we are the result of those stellar explosions. Every human being, every plant, and every animal is a manifestation of that dust that once floated in space. It is a profound and astonishing connection that unites us with everything around us. As we explore more about Earth and its history, we also realize how vulnerable we are. The conditions that allowed life to flourish are unique and delicate. Stardust, although it seems to be just another component of our existence, is a reminder that everything is interconnected. The cosmic forces that create and destroy are also the ones that shape our home. Science has made great strides in understanding this relationship between stardust and life on Earth. Research continues to reveal new aspects of how these cosmic elements have influenced the chemistry and biology of our planet. Each discovery is like opening a door to a new universe of knowledge. In the quest for answers about our existence, stardust stands as a fundamental pillar. It is a symbol of the interconnectedness between the universe and life, a reminder that we are all part of a much larger story. From the stars that shine in the sky to the molecules that make up our bodies, stardust is a thread that weaves everything together in the grand tapestry of the cosmos. So the next time you look up at the stars, remember that each twinkle in the sky is a testament to dust that over billions of years has contributed to the formation of Earth and life. We are made of stardust, and that is something truly extraordinary. As we continue to explore the universe, we must never forget that essential connection that unites us all. Stardust is, in essence, the material we are made of. But how is it possible that elements like carbon, oxygen, and nitrogen, which are fundamental to life, come from such a distant and mysterious place as space? The answer lies in the fascinating story of stardust and its relationship with biology on Earth. From the atoms that make up our bodies to the molecules that form the air we breathe, everything has an origin in the dust formed in stars. One of the most intriguing questions is, why is carbon so important? This element, found in every living being, acts as a fundamental scaffold for life. But where does it come from? When stars shine, they convert hydrogen into helium in their cores, but at the end of their lives, in their explosions, they generate a variety of heavier elements, including carbon. This carbon is scattered into space and becomes part of new stellar systems and planets, including Earth. Thus, each of us is, in a sense, a child of the stars. Oxygen, the second most abundant element in the human body, also has its origins in the stars. During the final stages of their lives, massive stars produce oxygen through nuclear reactions. After a supernova explosion, this oxygen is released into space, where it can be captured by new celestial bodies. Isn't it amazing to think that the air we breathe was created in the heart of a distant star? Nitrogen, another essential element, is also part of this stellar tale. Although it is a bit more complicated, nitrogen is formed during the life of stars and is dispersed at the end of their life cycle. This element is vital for the formation of proteins and nucleic acids, which are the building blocks of life. Without nitrogen, we could not exist. But what about minerals and other trace elements that are equally important for life? They all have their own journey through space. In supernova explosions, elements like iron, calcium, and phosphorus are created. These elements, like carbon and oxygen, are integrated into stardust. When this dust clumps together and forms new planets, it brings with it a variety of elements necessary for life. The connection between stardust and biology extends beyond the basic elements. Complex molecules, such as those that form DNA and proteins, also come from this same dust. When stars die, they release not only atoms but also compounds that can bond together to form more complex structures. These molecules are the foundation of the chemistry of life. The story of stardust doesn't end there. As dust forms in space, it can also influence the atmospheres of planets. For example, on Earth, stardust can act as a condensation nucleus for cloud formation. This means that dust is not only essential for life, but also plays a role in the planet's climate and water cycles. Moreover, stardust can have a direct impact on the evolution of life carried by solar winds to Earth. This dust can introduce new elements and compounds that may influence the development of life forms. For instance, certain minerals brought by dust have been found to be crucial for biological activity in extreme environments. Exploring this connection has led many scientists to wonder what other forms of life might exist on other planets thanks to stardust. If dust is essential for life here on Earth, could it also be so on other worlds? In this sense, stardust not only becomes a raw material for life, but also a possible indicator of the existence of life in the universe. The biology and chemistry of life on Earth are deeply intertwined with the history of stardust. Every time we look at the starry sky, we are seeing a reminder of the journey that has brought us here. The next time you breathe, remember that the air filling your lungs has a stellar origin, the interconnectedness between stars. Dust and life is a reminder that we are part of something much larger. Through this cosmic web, stardust becomes the thread that binds all living beings on Earth, reminding us that ultimately we all share the same origin. This dust connects us not only with our planet, but also with the vast universe that surrounds us. So the next time you gaze at the stars, remember that each spark in the sky is not just light, but a link to life itself. Have you ever contemplated the vastness of the universe and wondered if there is life beyond our planet? The search for life on other worlds is one of humanity's greatest challenges. A fundamental element that could be at the heart of this search is stardust. But how can something so tiny and seemingly insignificant play such a crucial role in the quest for life in the cosmos? In nature, life as we know it is composed of elements like carbon, oxygen, nitrogen, and iron, among others. Surprisingly, all of these elements originate from stars. When a star dies, it explodes in a supernova, releasing enormous amounts of stardust into space. This dust, which at first glance seems like just cosmic residue, is loaded with the ingredients necessary for life. Isn't it amazing to think that every breath we take could be connected to these cosmic explosions? As we explore space, the question arises, how can we trace stardust and its relationship to life? Scientists have begun to study the dust traveling through the solar system. By analyzing this dust, they can identify the elements that make up not only Earth, but also other planets and moons. What clues does this dust offer us about our existence? Let's think about Earth, a small corner of the universe where life flourishes. Researchers have discovered that comets and meteorites, which contain stardust, impact our planet. These impacts have been responsible for bringing organic compounds that could have been the initial ingredients for life. Could it be that life on Earth in its purest essence is the result of an interstellar journey? The chemistry of stardust is fascinating. Each grain of dust contains a variety of elements and chemical compounds. Some of these are capable of forming complex molecules, which is essential for life. What does this mean for other planets? In places like Mars or Europa, one of Jupiter's moons, scientists are searching for these same compounds. If found, they could be signs that life, as we know it, might exist there too. As telescopes advance, the search becomes more exciting. Astronomers are developing new technologies to detect stardust in other solar systems. Imagine being able to look through a telescope and see the remnants of a supernova in real time and think that those remnants could be seeding life on a distant planet. How fascinating would that be? Astrobiology, a discipline that combines biology and astronomy, focuses precisely on these questions. Scientists are formulating hypotheses about how stardust could be fundamental in the creation of life. If we consider that dust contains the building blocks of organic matter, Could it be that life is not a unique phenomenon of Earth, but a process occurring in different parts of the universe? However, it is not all that simple. The search for life on other planets also leads us to reflect on the diversity of conditions required for life to thrive. Stardust may contain essential elements, but it also needs a suitable environment. What kind of conditions would we be looking for? Perhaps an ocean of liquid water or an atmosphere rich in oxygen. Dust is just one part of the puzzle. Interest in stardust is not limited to astrobiology. Scientists are beginning to understand that dust could also have a significant impact on the formation of galaxies and stellar systems. How does this relate to the possibility of life? As new stars form from stardust, new planetary systems are also created. Each new system could potentially harbor life. In the search for life, collaboration between disciplines is key. Astronomers, biologists, chemists, and physicists are coming together to discover how stardust could connect all these fields. In doing so, they are opening new avenues for research. What unexpected discoveries could arise from this collaboration? The interconnection between stardust and life raises philosophical questions. If all the elements that make up our bodies were created in the heart of a star, what does this mean for our identity as human beings? Are we really made of stars? This deep connection reminds us that we are not just inhabitants of Earth, but part of a much larger universe. As we continue to explore the cosmos, stardust becomes a symbol of hope and discovery. Each grain of dust is a bridge to the past and a pathway to the future. In every particle, there are stories of stars that lived and died, and of worlds in formation. What new stories will be revealed as we continue our search? The exploration of life on other planets and the understanding of stardust lead us to reflect on our own existence. Are we alone in the universe? Or are we part of a vast ocean of life that extends beyond what we can imagine? The answer may lie in the dust that floats silently in space, waiting to be discovered. With each discovery, the connection between stardust and life becomes more evident. The next time you look at the starry sky, remember that each star, each supernova has contributed to the matter that makes up our being. In that cosmic dust, we find not only the secrets of the universe, but also the essence of our own existence. So what does the future hold for us in our quest for life in the cosmos? Stardust has much to tell. Throughout the history of astronomy, scientists have developed a variety of methods to observe the cosmos. But how can we see something as small and elusive as stardust? The answer is fascinating and full of human ingenuity. Astronomers have used powerful telescopes, both on Earth and in space, to study this cosmic material, revealing secrets that help us understand not only the universe but also our place within it. Optical telescopes are one of the most traditional tools in astronomical observation. They work by capturing visible light from stars and other celestial objects. However, stardust, being so faint and dispersed, can be difficult to detect with this type of telescope. So what do scientists do? They use telescopes that operate at other wavelengths such as infrared and microwaves. These telescopes can see through the dust, allowing astronomers to observe the processes of star formation and the distribution of dust in galaxies. Infrared technology has been revolutionary in this regard. Imagine a cloudy day when you can't see the sun. However, if you have infrared glasses, you could feel its heat even through the clouds. This is how infrared telescopes work in space. They can detect the light emanating from newly born stars and clouds of dust that would otherwise remain hidden. With this technique, we have been able to examine dense regions of space where new stars and planets are forming. It's like looking behind a curtain to discover the magic happening on stage. But not only telescopes on Earth are useful. The observation of stardust has greatly benefited from space telescopes such as Hubble and the more recent James Webb. By being outside the Earth's atmosphere, these telescopes can collect light without the distortion caused by the air we breathe. This means they can obtain sharper images and finer details of galaxies and dust clouds. It's like comparing a photograph taken on a sunny day with one taken in the middle of a storm. The clarity is incomparable. Scientists have also sent space probes to study stardust up close. These spacecraft, like stardust, have traveled to comets and asteroids, collecting samples of dust and particles. Imagine throwing a net into the sea and catching small marine creatures to study their biology. This is how these probes work. They bring back fragments of stardust that tell us the story of the solar system and beyond. Through these samples, scientists have discovered that some of the materials in stardust are older than the sun itself, offering a window into the primitive past of the universe. Spectroscopy is another crucial tool in the astronomer's arsenal. Through this method, scientists can break down the light from stars and dust into different wavelengths. Like a rainbow, each chemical element has a unique fingerprint in the spectrum, allowing astronomers to identify the composition of stardust and its origin. Think of it as listening to a song and being able to identify which instruments are being used just by the sound. This technique has allowed researchers to better understand what elements are present in the dust and how they form. Images of stardust are truly stunning. They are often presented as clouds of bright colors and irregular shapes that seem to dance in space. These images are not only beautiful but also tell stories. Each dust cloud can be a place where new stars are forming, or where material from dying stars is dispersed throughout the cosmos. Can you imagine being an explorer in an ocean of stars, navigating among these colorful clouds? As astronomers continue to refine their observation methods, each discovery brings us a little closer to understanding the vast network of stardust that forms the fabric of the universe. Every particle of dust has a story to tell. And through observation, we are uncovering secrets that have remained hidden for billions of years. The importance of stardust in our understanding of the universe cannot be overstated. It not only helps us understand how stars and planets form, but also provides information about the evolution of the cosmos. Each new advance in observation technology opens the door to surprising discoveries, and each discovery leads us to new questions. Stardust is not only an essential component of matter in the universe, but also a reminder of our connection to the cosmos. Every time we look up at the sky, we are observing the result of millions of years of stellar evolution, and the dust we see is a part of that story. So the next time you gaze at the stars, remember that stardust is not just a simple cosmic material. It is a fundamental part of our existence. And so, as we explore the universe and its mysteries, stardust will continue to be a fascinating topic, a thread that connects life on Earth with the stars in the sky. The quest for knowledge about this essential material invites us to reflect on our place in the vast cosmos and encourages us to keep exploring, questioning, and discovering. After all, the universe is full of surprises, and stardust is just the beginning of a story that is yet to be written. Have you ever looked up at the starry sky and wondered what lies behind the beauty of those bright points? Every star we see in the darkness has a story to tell, and that story is intimately connected to stardust. This dust, a product of the life cycles of stars, has played a fundamental role in the evolution of the universe. But how has stardust influenced the history of our cosmos? To understand the influence of stardust, it is essential to go back in time. Imagine a moment when the universe was young, filled with gas and dust, but lacking the diversity of matter we know today. The first generations of stars began to form, and as they shone and died, they released fundamental elements into space. These stellar explosions, known as supernovae, not only illuminated the sky but also scattered their contents throughout the cosmos. In this context, stardust becomes the thread that weaves through cosmic history. But why is it so important? Think of dust as the ingredients of a cosmic recipe. When stars explode, the elements they have created during their lives mix and disperse into space, forming a kind of soup of matter. This mixture is essential for the creation of new stars, planets, and eventually life itself. Without this dust, the universe would be a very different place, a vast void lacking the structures we know today. One of the intriguing questions that arise is, what happens to stardust over time? As stars die and release their contents, the dust embarks on a journey. It clumps together, cools, and condenses into dense clouds that eventually collapse under their own gravity, giving rise to new stars. This endless cycle of creation and destruction is what keeps the universe in constant evolution. Isn't it fascinating to think that the dust that once formed part of a distant star could, at this moment, be part of a new stellar system? Stardust not only contributes to the formation of stars and planets, it also plays a crucial role in the structure of the universe. When we observe galaxies, what we are seeing is a mix of stars, gas, and dust. This dust can act as a shield, absorbing light from stars and creating shadows that shape galactic structure. Without dust, galaxies would not have the same shape or color. But how do we know that stardust has such a significant impact? Astronomers have developed various ways to observe and analyze stardust. They use telescopes that capture wavelengths of light that are not visible to the human eye. This allows them to detect the signature of dust in galaxies and study its distribution. This enables them to understand how dust has influenced the formation of cosmic structures over time. Imagine how scientists can reconstruct the history of the universe from these tiny particles. It's like piecing together a cosmic puzzle. One question many people ask is there stardust in our own solar system? The answer is a resounding yes. On Earth, we constantly receive tiny particles of stardust that come from space. These fragments, often invisible, are witnesses to the history of stars that died millions of years ago. Every grain of dust that falls on our planet is a reminder that we are connected to the universe on a very deep level. Stardust has also played a leading role in the development of life on Earth. The elements that make up this dust are the foundation of organic chemistry. Without carbon, oxygen, and other elements formed in stars, life as we know it would not exist. This leads to a profound reflection. In every living being on our planet, there are pieces of stars. It's a direct connection that binds us to the vastness of the cosmos. When thinking about the history of the universe, we cannot forget that stardust has also contributed to the formation of clouds of gas and dust that become new generations of stars. This stellar life cycle is an endless journey that shapes the structure of the universe. Through these stages, dust transforms and reinvents itself, demonstrating that the death of a star is just the beginning of something new. Modern cosmology teaches us that stardust is not just a passive component of the universe, but plays an active role in its evolution. As galaxies form and evolve, dust acts as an agent of change, influencing how stars and planets develop. This dynamic is a reminder that the universe is in constant motion, always in a flow of creation and destruction. Reflecting on stardust and its history raises questions about our own future. As the universe continues to expand, what role will dust play in the next stages of its evolution? Will it continue to be an essential component in the creation of new stars and planetary systems? The answer to these questions leads us to consider how stardust will remain a key player in the narrative of the cosmos. In conclusion, stardust is much more than a simple collection of particles. It is a witness to the history of the universe, an essential component in the creation of stars, planets, and life. It connects us to the past and invites us to reflect on our place in the vast cosmos. So the next time you look up at the sky, remember that those stars and the dust that accompanies them are part of a story much larger than ourselves. Each grain of dust has a story to tell, and that story is one of the creation of the universe and the life we know. Stellar dust, that tiny and seemingly insignificant material, plays a fundamental role in understanding cosmology. Have you ever wondered how something so small can have such a big impact on the structure of the universe? The answer lies in how stellar dust interacts with matter, energy, and gravity in the vast cosmos. First, let's think of the universe as a large blank canvas. Each star, every galaxy, and every particle of stellar dust are like brushstrokes that shape this cosmic masterpiece. Without stellar dust, this canvas would be empty and devoid of color. But where does all this dust that seems to be everywhere in space come from? It comes from stars, which throughout their lives and deaths release this material into the environment, creating what we know as the interstellar medium. The geometry of the universe is not static, it is constantly changing. When we observe galaxies, we notice that they are composed of stars, gas, and dust. This stellar dust acts as a cosmic glue. Without it, stars could not form. It is in the dense and dark dust where molecules cluster and begin to form new stellar systems. Isn't it fascinating to think that the same material that once was in a dying star can become our sun and the planets that surround it? Speaking of gravity, this is the force that keeps everything in place. Stellar dust plays a crucial role in creating gravity. When it clumps together, it begins to attract more matter around it, forming dense clouds that eventually collapse to give rise to new stars. Thus, dust becomes the architect of the cosmos, shaping the structure of the universe on a grand scale. But what about the expansion of the universe? This is where stellar dust also has something to say. As the universe expands, stellar dust disperses. This dispersion is not random. It is controlled by gravity and the dynamics of galaxies. Through observation and study, astronomers have been able to track how dust is distributed and moves through space. This is essential for understanding cosmic evolution. Did you know that stellar dust can also influence the temperature of the universe? As it accumulates, it can absorb and emit light, affecting the radiation we perceive. Now let's reflect on the role of stellar dust in the formation of larger structures such as galaxy clusters. When dust clumps and condenses, it creates clusters that can attract more matter around them, forming large structures that we see in the universe. This process is similar to how bubbles form in a milkshake. Small air bubbles group together and form larger bubbles. In fact, gravity is like the spoon that mixes everything, causing these bubbles to merge. But how do we know all this? The answer lies in the science of observation. Telescopes and space probes have allowed astronomers to study stellar dust at different wavelengths. By observing the dust, we can better understand its composition and distribution. Through this research, we have discovered that dust is more than just small particles. It is an essential component that tells the story of the universe. Imagine that each particle of stellar dust is a small book that narrates the life of a star. By reading these books, scientists can better understand the history of the universe. This narrative is not only about stars and galaxies, but also about the evolution of matter itself. Each grain of dust has been part of a fascinating journey, from its creation in the heart of a star to its dispersion in the vast universe. In the context of cosmology, stellar dust also plays a role in the study of dark matter and dark energy. Although these are mysterious entities, dust can help scientists better understand their influence on the structure of the universe. With each discovery, we get a little closer to unraveling the secrets of the cosmos. One particularly intriguing aspect is how stellar dust can affect galaxy formation. As dust accumulates and forms dense clouds, these clouds can collapse under their own gravity, giving rise to new stars and galaxies. Thus, dust is not only a product of the death of stars, but also the precursor to new generations of celestial bodies. It's as if stellar dust has its own life cycle, where each cycle feeds the next. As we reflect on the role of dust in cosmology, it is important to consider that the universe is an interconnected system. Every star, every galaxy, and every particle of dust is related. The interactions between them shape the evolution of the cosmos. Thus, stellar dust is not only part of the story of stars, but also of ours as human beings who inhabit a small corner of this vast universe. Finally, as we close this chapter on stellar dust and its relationship with cosmology, it is essential to remember that each grain of dust, each star, and each galaxy is part of a larger whole. Stellar dust is more than just matter. It is a reminder that we are all connected in the great tapestry of the universe. As we continue to explore and learn more about the cosmos, stellar dust will remain a fundamental thread that weaves together the story of the universe and our own existence. Since time immemorial, humans have looked up at the starry sky and felt a deep connection with the universe. But what is really out there among those stars? How has stardust influenced cultures throughout history? This dust, which may seem insignificant at first glance, is actually a crucial component that has inspired myths, legends, and philosophies in various civilizations. In ancient times, stars were seen as gods or supernatural entities. The Greeks, for example, imagined that the dust shining in the sky was the residue of the souls of fallen heroes. This belief gave them a sense of connection to the divine, as if the universe spoke to them through the light of the stars. By observing the night sky, they felt part of something much larger, as if each grain of stardust told a story. Mesoamerican civilizations, such as the Maya and the Aztecs, also had their own interpretation of stardust. For them, the cosmos was filled with deities, and the dust that fell to earth was considered sacred. They believed that this dust had the power to influence crops and weather, and thus held ceremonies to honor the gods of the sky. In their view, dust was not only part of the universe but also an integral part of their daily lives. As time progressed during the Renaissance, stardust began to be seen in a new light. With the advent of modern astronomy, figures like Galileo and Kepler started to study the stars and their movements. In this context, stardust became a symbol of knowledge and the quest for truth. Human curiosity to understand the cosmos soared, and dust, which had previously been just a visual phenomenon, acquired a new meaning as an integral part of the universe's creation. Poetry has also found in stardust an inexhaustible source of inspiration. Poets of all ages have spoken about the connection between dust and life, using metaphors that evoke the fragility of existence. Dust becomes a reminder that we are all part of an endless cycle of creation and destruction. Thus, every human, every plant, and every animal carries with it a portion of that dust that has traveled through time and space. Art has not been immune to this fascination. Painters and sculptors have been captivated by the beauty of the cosmos, creating works that reflect the majesty of the stars and their dust. The representation of constellations and nebulae in painting allows viewers to dream and question their place in the universe. Stardust thus becomes a bridge between science and creativity, uniting knowledge with emotion. Some philosophers have gone further, reflecting on the meaning of stardust in our existence. They have wondered whether we are simply stardust that has come to life, or if there is a greater purpose to our journey. These profound questions have led to debates about the nature of life, death, and the fate of the universe. In this sense, dust transforms into a symbol of humanity's search for meaning. We cannot forget the influence of science fiction on our perception of stardust. Authors like Arthur C. Clarke and Isaac Asimov have imagined futures where stardust is key to space exploration and the search for life on other planets. In these narratives, dust becomes a vital element that connects humans with alien civilizations and distant worlds. Imagination soars and dust becomes a symbol of infinite possibilities. As humanity advances in its understanding of the universe, stardust has been the subject of study not only in science but also in theology. Many religions have incorporated the idea that we all come from the same cosmic material, promoting a vision of unity among all living beings. This perspective invites us to see ourselves as part of a whole, where the dust that composes us connects us all on a shared journey through the universe. Recently, with the development of astrobiology, stardust has gained even more importance. Research has suggested that some compounds in dust may be essential for life. This has led to a renewed interest in stardust in the search for life on other planets. The possibility that the dust forming our biology has a common origin in the cosmos makes us reflect on our own existence. Stardust has also found its way into education and scientific outreach. With the rise of technology and the arrival of advanced telescopes, discoveries have amazed millions. This knowledge not only fuels curiosity, but also inspires new generations to look up at the sky and question their place in the universe. The connection between dust and education is a reminder that knowledge is a continuous journey. The interaction between stardust and culture in general is a testament to how humans have sought answers to the deepest questions of existence. From ancient stories to modern theories, dust has been a common thread in the narrative of humanity. Each story, each myth, each discovery brings us a little closer to understanding our place in the vast cosmos. In a world where science and spirituality often seem to be in conflict, stardust emerges as a symbol of reconciliation. It reminds us that despite our differences, we all share a common origin and that each of us is part of a much larger spectacle. In the search for answers, stardust invites us to keep exploring, dreaming, and questioning. In the end, stardust is not just a physical element, it is also a symbol of the connection between all living beings and the universe. It reminds us that, although we are small compared to the vastness of the cosmos, our stories and experiences are equally valuable. Thus, when we look up, we can find not only stars but also our place in the fabric of the universe. Science has found fascinating ways to approach the mysteries of the universe, and one of the most intriguing methods is recreating the conditions of space in laboratories here on Earth. How is it possible for scientists to simulate the hostile environment of the cosmos? The answer lies in human ingenuity and advanced technologies that conduct experiments to better understand stardust and its properties. Scientists use vacuum chambers, which are like large containers that simulate the conditions of space. Can you imagine being in a place where there is no air, where particles float without resistance? This is how they resemble the conditions of the universe. In this environment, researchers can study how stardust forms and how it interacts with light and other particles. It's like a large cosmic laboratory where they can closely observe the secrets of the universe. One of the most intriguing questions scientists ask is, what happens to stardust when it is in space? In the laboratory, researchers can experiment with different substances and conditions to see how dust grains form, which are actually aggregates of atoms and molecules. This allows them to understand not only the dust that floats in space, but also that which may exist on other planets or in the formation of new stellar systems. A surprising aspect of these experiments is the creation of miniature dust clouds. How is that achieved? By using cooling techniques and lasers, scientists can cause dust particles to cluster and form more complex structures. This process is similar to what happens in space, where gravitational forces and chemical interactions allow dust to clump together and form planets and stars. But what can be learned from these miniature clouds? By studying how they behave, researchers can gain insights into how dust behaves in the vast universe. The study of stardust also delves into the intriguing field of astrobiology. Scientists are trying to understand how dust may contain the building blocks of life. In the laboratory, they can simulate the chemical reactions that might have occurred in the early days of Earth. Could it be that stardust brought with it the necessary ingredients for life? By analyzing the molecules that form under these conditions, researchers seek to answer this fundamental question. Another fascinating question is, how do the conditions of these experiments relate to what happens in space? The answer lies in the fact that although laboratories cannot perfectly replicate space, they can mimic many of its aspects. For example, by cooling gases and causing them to collide, researchers can observe how complex compounds form, something that also occurs in the interstellar clouds where stardust originates. Furthermore, scientists have developed techniques to study the chemical composition of dust in the laboratory. By using spectroscopy, they can break down the light emitted by dust and analyze the different elements present in it. This technique is similar to how astronomers analyze the light from stars and galaxies to determine their composition. By understanding what elements are found in stardust, scientists can make connections about how these elements are distributed in the universe and their importance in the formation of new celestial bodies. Research in the laboratory is not limited to simulating dust formation. It also includes studies on its impact on the Earth's environment. What effects could stardust have on the Earth's atmosphere? Scientists are beginning to explore how dust particles, which come from space, can influence climate patterns and the health of the planet. This multidisciplinary approach reveals that stardust is not only a component of the cosmos but also has implications for our own home. The advancement of technology has allowed scientists to use computer simulations to visualize and predict the behavior of stardust under different conditions. These models are like maps of the universe that help researchers better understand how dust is distributed in galaxies and how it can affect the evolution of stars and planetary systems. Through simulations, they can study scenarios that would be impossible to observe directly in space. With each advance in recreating space conditions, researchers get closer to unraveling the secrets of the cosmos. What other surprises does stardust hold for us? As technology advances, laboratories are expected to continue playing a crucial role in exploring these mysteries. Human curiosity and the desire to understand the universe lead us to places we never imagined. And stardust is just one of the many pieces of this vast puzzle. The combination of laboratory experiments and observations in space creates a feedback loop of knowledge. What we learn on Earth helps us interpret what we see in the cosmos, and vice versa. Each discovery reveals more about the nature of the universe and at the same time reminds us of our own connection to it. Finally, the study of stardust in the laboratory is not just a scientific quest. It is a search for our place in the universe. As we explore how it forms and how it influences life, we are also exploring our own existence. Stardust, which began as the material of dying stars, has become a thread that connects the cosmos and life on Earth, reminding us that we are all part of this immense and wonderful story. Stellar dust, although it may seem insignificant at first glance, plays a crucial role in the functioning of our planet and in life as we know it. But how can something so small and seemingly harmless influence the climate and geological processes of Earth? To understand this, it is first important to know the nature of stellar dust. This cosmic material is the result of star explosions and the death of gas giants. When a star reaches the end of its life, it releases enormous amounts of dust and gas that disperse through space. This dust, being part of the primordial matter of the universe, has the ability to travel vast distances and eventually land on our planet. But what happens when this dust arrives on Earth? When stellar dust enters the Earth's atmosphere, it becomes an essential component in cloud formation and therefore in the water cycle. Have you ever wondered how clouds are formed? Dust acts as a nucleus around which water vapor can condense. Without this dust, cloud formation would be much more difficult, which could affect the amount of precipitation we receive. Imagine a world where rain is scarce. Without stellar dust, many regions of the planet could become arid and desert-like. Furthermore, stellar dust contains elements such as carbon and oxygen, which are fundamental for life, being part of the composition of clouds. These elements can fall to the ground when it rains, enriching the soil and promoting plant growth. Thus, the cycle of stellar dust intertwines with the cycle of life on Earth, creating a system in which everything is connected. Isn't it fascinating to think that what appears in our sky can influence the growth of a tree or the production of food? But the impact of stellar dust is not limited to water and vegetation. Scientists have discovered that this material can also affect the climate in more complex ways. For example, dust can influence the Earth's temperature by reflecting or absorbing sunlight. In certain situations, stellar dust can contribute to a temporary cooling of the planet, while in others, it can warm the atmosphere. How can something so small have such a big effect on global climate? Studies have shown that during periods of intense volcanic activity or prolonged droughts, stellar dust can be an important factor in climate regulation. Imagine that stellar dust is like a giant thermostat, helping to balance the Earth's temperatures. However, in a world where human activities have altered the climate, the role of stellar dust becomes even more intriguing. The interaction between stellar dust and the atmosphere can also influence extreme weather phenomena such as storms and hurricanes. By modifying the temperature and humidity of the air, stellar dust becomes a player on the meteorological stage. Is it possible that this small cosmic component is behind some of the most powerful storms we have experienced? In addition to its influence on the climate, stellar dust can play a role in the geological processes of Earth. For example, when it falls over the oceans, this dust fertilizes the waters, promoting the growth of phytoplankton. This microorganism is the base of the marine food chain and in turn produces vital oxygen for life on our planet. Thus, stellar dust not only nourishes the soil, but also our oceans. Who would have thought that space dust could be so crucial for marine life? Scientists are beginning to understand that stellar dust could also be related to climate change. As Earth experiences changes in its temperature and climate, the dust cycle may be altered. This can lead to changes in how clouds form and, consequently, in the amount of rain we receive. The implications of this are enormous, as they could affect agriculture, water availability, and ultimately the survival of many species, including our own. The study of stellar dust is not only crucial for understanding our planet, but it also offers us clues about the history of the universe. Every grain of dust that falls to Earth is a reminder that we are connected to the cosmos in a way that goes beyond our everyday understanding. Isn't it amazing to think that every time we breathe, we are inhaling the remnants of stars that existed millions of years ago? In conclusion, stellar dust is much more than just a simple cosmic residue. Its influence on climate, geological processes, and life itself is a testament to the interconnectedness of all elements in the universe. In a world where we often feel disconnected from nature, stellar dust reminds us that we are part of something much larger and that every small component plays a vital role in the grand scheme of life. So the next time you see a cloud in the sky, think about the stellar dust that may have contributed to its formation and how this small material has such a big impact on our world. What if I told you that stardust has a fascinating and enigmatic future that could influence the evolution of the universe as we know it? As we delve into the future of stardust, it is essential to understand that this cosmic component is not just a remnant of dead stars. Its history is intrinsically linked to the life cycle of the universe. But what exactly is that future? Imagine a vast cosmic workshop where stars are the artisans and stardust is the material that transforms into new creations. Each grain of dust tells a story, and as the universe continues to expand, this dust becomes the raw material for the formation of new stars and planetary systems. But how will this process look in the millions of years to come? Over the next billions of years, stars will continue to be born, live, and die. In their death, they will release more stardust into space. This dust, which is often a mix of essential elements like carbon, oxygen, and nitrogen, will clump together, forming new molecular clouds. Can you imagine what will happen when these clouds condense into new stars? Each new generation of stars will be a reflection of the dust that preceded them. But beyond star formation, stardust also plays a crucial role in how planets are grouped. The planetary systems that will form in the future will depend on the quantity and quality of the available dust. What does this mean for the search for life on other planets? If stardust brings with it the basic ingredients for life, we could be witnessing the emergence of habitable worlds in places we can hardly imagine. In a distant future, stardust could also be an indicator of how the universe will behave. As stars die and dust disperses, this material may influence the structure of galaxies. Could stardust be the key to understanding the expansion of the universe? The answer may lie in the properties of the dust and how it affects gravity and dark matter. The story of stardust is not limited to the formation of stars and planets. As galaxies evolve, dust may be responsible for creating new cosmic structures. Some theories suggest that stardust can act as cosmic glue, helping to bind matter together and forming new galaxies. Can you imagine a universe where dust is the builder of new cosmic realities? Moreover, stardust could impact phenomena that we do not yet fully understand, such as dark energy. As the universe expands, dust could interact in ways that help us better understand this mystery. Could stardust be a small brick in the construction of the theory of everything, which seeks to explain all phenomena in the cosmos? And let's not forget that stardust also has a direct connection to our planet. As dust accumulates and transforms, the cycles of star and planet formation may influence our own existence. How will this change our understanding of life on Earth? It could be that parts of ourselves are made of stardust, and that our future is intertwined with that of the stars. In the future, advanced technology could allow us to study stardust in ways we can only dream of today. With more powerful telescopes and probes traveling to the far reaches of the solar system, we could discover new types of dust and their properties. What surprises will stardust hold in these new discoveries? The search for life on other planets could also benefit from the study of stardust. If dust contains the necessary ingredients for life, scientists might look for signs of this material on exoplanets. Could stardust be a map guiding us toward new habitable worlds? Imagine the excitement of discovering a planet where life, in some form, could be thriving. As we enter this new era of space exploration, stardust will remain a topic of interest. The questions that arise are endless. What other secrets does it hold? How will it influence the evolution of our galaxy? Could it be a fundamental element in the history of the universe that we have yet to fully understand? In the end, the future of stardust is as vast as the universe itself. As we continue to explore and learn, each discovery will bring us closer to understanding our place in the cosmos. So the next time you look up at the starry sky, remember that each particle of stardust has a story to tell and a future to explore. Perhaps in some corner of the universe, a new star is about to be born, nourished by the dust that once was part of another. And thus the cycle continues, ever more intricate and surprising. Stardust, that fascinating material that floats in the vast cosmos, is often portrayed in popular culture as something magical and mysterious. But do we really know what it is and how it influences our lives? Let's demystify some common misconceptions about this intriguing component of the universe together. A common misconception is that stardust is just an insignificant residue. However, this dust is, in fact, the fundamental raw material of everything we know. When we think of dust in space, we might imagine tiny specks floating around, but in reality, each particle of stardust is a fragment of cosmic history, a legacy of stars that have lived and died. Each grain of this dust contains elements that have traveled through billions of years and have contributed to the formation of planets, stars, and of course, life itself. What about the belief that stardust is dangerous? It is often mentioned that space dust can affect health. However, the stardust that reaches Earth is mostly harmless. While it may seem like we are surrounded by strange particles, most of the time this dust breaks down in the atmosphere and does not pose a significant risk. So if you've ever worried about it, breathe easy. A frequently asked question is whether stardust is visible. The answer is more complex than it seems. From Earth, we cannot see every tiny particle, but we can observe large clouds of dust that are part of nebulae. These clouds are so dense that they can obscure the light of the stars behind them. In this sense, stardust is part of a cosmic spectacle, acting as a canvas on which the stories of the universe are painted. Some think that stardust is a phenomenon exclusive to distant galaxies. However, stardust is present in our own galaxy, the Milky Way. In fact, it is part of what surrounds us, even on Earth. Every time we look up at the sky, we are seeing a universe full of stardust. This fact intimately connects us with the cosmos, making us feel part of something much larger. Another common myth is that stardust only forms from supernovae. While supernovae are an important source of dust, they are not the only ones. Stars in different stages of their lives also generate dust. For example, when a sun-like star becomes a red giant, it expels material into space, which eventually becomes dust. So in reality, stardust is produced under various circumstances throughout the lives of many stars. People often wonder if stardust has any relation to Earth in terms of composition and origin. Absolutely. The elements that make up stardust are the same ones that form the matter on our planet. Carbon, oxygen, iron, and many other elements essential for life come from this dust. This leads us to a surprising conclusion. We are truly stardust, a statement that resonates deeply in our existence. Let's talk about the idea that stardust is static and unchanging. In reality, dust is dynamic and constantly moving. Gas and dust currents move through space, interacting and forming new stars and planetary systems. This perpetual cycle of creation and destruction is fundamental to the evolution of the universe. Another intriguing question arises. Could stardust be the origin of life? The answer is yes, to some extent. The compounds formed in stardust may be the building blocks of life. In laboratories around the world, scientists are investigating how complex molecules can arise from stardust, which could offer clues about how life began on Earth and whether it could exist elsewhere. Some people think that stardust is something that can only be studied from telescopes, but this is not entirely true. Scientists use advanced technologies such as laboratories and simulations to recreate the conditions of space and study how stardust behaves. This allows us to better understand its composition and properties, further demystifying its nature. The belief that stardust has no impact on our planet is another myth to debunk. Stardust can influence phenomena such as climate by affecting cloud formation and rainfall. Additionally, the dust that falls to Earth can enrich soils, providing essential nutrients to our ecosystem. All of this demonstrates that stardust is not just a background element in the universe, but plays an active role in life on Earth. Finally, it is important to remember that stardust has captured the imagination of artists and writers throughout history. From poetry to science fiction, this material has been interpreted in multiple ways, reflecting our curiosity about the cosmos and our search for meaning in our existence. Who hasn't felt small when contemplating the vast universe and the dust that composes it? At the end of the day, understanding stardust helps us better comprehend our place in the universe. It connects us with the stars, with the history of creation, and with the very essence of life. So the next time you look up at the sky, remember that you are not just seeing stars, but also the dust that gave rise to everything you know. Stardust has captured the imagination of writers and filmmakers for generations. But why has it been such a recurring theme in science fiction? To understand this, we must first delve into the fascinating world of the elements that make up our universe. From epic tales to intimate stories, stardust has become a powerful metaphor that connects the cosmic with the human. How is it possible that a simple grain of dust can hold so much meaning? Narratives about stardust reflect our search for our place in the cosmos. In many works of science fiction, dust is seen as the beginning of everything, an essential component in the formation of stars and planets. But what does that really mean for us? Imagine that every star shining in the sky is like a beating heart in the universe, and the dust surrounding it is the blood that nourishes its existence. This poetic image suggests that we are part of an eternal cycle of creation and destruction. One of the most emblematic stories that incorporates stardust is The Never-Ending Story by Michael Ende. In this work, dust is associated with fantasy and the creation of worlds. Each particle represents a possibility, a new life waiting to be discovered. In this sense, dust is not just matter, but also potential, leading us to wonder, what if what we consider reality is just stardust in constant transformation? The Star Wars series also delves into the theme of stardust. Often characters travel through vast expanses of space, where cosmic dust seems to be an omnipresent element. This dust not only acts as a backdrop, but also symbolizes the journey of heroes. What lessons can we learn from these intergalactic journeys? Perhaps it is about the search for identity and meaning, aspects that resonate deeply in human experiences. In Interstellar, stardust plays a crucial role in the narrative. Through the exploration of wormholes and time travel, characters discover that dust is not just a physical phenomenon, but is also linked to the notion of love and connection between beings. Could it be that stardust in its essence represents the interconnectedness of all lives? This idea invites reflection on how each of us is intertwined with the universe. Science fiction authors often use stardust as a symbol of mystery. In Dune, by Frank Herbert, the dust of the planet Arrakis is vital for the survival of its civilization. This dust, which becomes the most valuable spice in the universe, is associated with power and transformation. What does this tell us about how we value resources in our own world? Dust can be both a resource and an obstacle, depending on how we manage it. In literature and film, stardust is often the catalyst for extraordinary events. What if I told you that in the Hunger Games, dust and ash become a symbol of oppression and the struggle for freedom? The representation of dust as a reminder of what has been lost resonates with many realities in our world. It invites us to question how the dust of our history can shape our future. Stories of intergalactic travel also address the idea that stardust can be a means of communication. In Contact by Carl Sagan, cosmic dust acts as a channel through which messages from advanced civilizations are transmitted. This concept raises an intriguing question. Are we listening to the whispers of the universe around us? Or are we too absorbed in our own lives to notice the signals? Science fiction not only entertains but also challenges us to think about the ethics and morality of our relationship with the universe. In Blade Runner, dust becomes a reminder of the fragility of life and the search for humanity. This struggle to define what it means to be human leads us to ask, are we merely dust in the wind, or is there something more to our existence? In the realm of animation, films like Wall-E explore the impact of dust and pollution on Earth. The representation of dust as a symbol of neglect and abandonment provokes reflection on our responsibility towards the planet. How can we ensure that the dust we leave behind does not become a legacy of destruction but one of renewal? Stardust has also found its way into poetry and music. Who hasn't felt inspired by the idea that we are all made of stardust? This notion has permeated popular culture, from songs celebrating our connection to the universe to poems evoking the ephemeral beauty of existence. This blend of science and art reminds us that while we are fragile, we are also extraordinary. The future of science fiction and stardust is promising. With advances in technology and space exploration, stories will continue to evolve. Dust will become a symbol of discovery and wonder, inviting us to explore new worlds and possibilities. What new stories are yet to come? Perhaps we are awaiting tales of civilizations that have learned to live in harmony with the dust of their own worlds. Science fiction offers us a mirror in which to reflect on our relationship with the universe. Through these narratives, stardust becomes a powerful metaphor for our search for meaning and connection. It teaches us that, although we are just a tiny grain of dust in the vast expanse of the cosmos, each of us has the potential to shine and leave a mark on the universe. In the end, stardust reminds us that we are part of something much larger. It invites us to question our beliefs, explore our limits, and connect with the cosmos around us. As we continue to look toward the stars, perhaps the dust we see is not just the residue of creation, but the beginning of new stories waiting to be told. Stardust is more than just a collection of particles. It is a reminder of the interconnectedness of everything that exists in the universe. What role does this dust really play in our daily lives? To understand the magnitude of its influence, it is essential to look back and appreciate each step we have taken together on this cosmic journey. Throughout our exploration, we have discovered that stardust is the result of eternal cycles. Stars are born, live and die, and in each of those phases they gift us fundamental elements that make up everything we know. Did you know that in a sense we are all stardust? When we look at the starry sky, we do not just see twinkling lights, but a direct connection to the history of the universe. Each star that shines in the night is a reminder of the cosmic dance that has shaped our home. The importance of stardust transcends its origin. This dust, formed from the death of stars, becomes the fundamental building block of new stars, planets, and of course, life. It is as if the universe is constantly recycling its materials, creating a symphony of elements that intertwine in an infinite cycle. How could something so small have such a significant impact on the vastness of the cosmos? When we consider Earth, it is fascinating to realize that each of us contains elements that once belonged to a distant star. Every breath we take, every molecule of water, every atom in our bodies has a stellar origin. This fact not only connects us to the universe, but also invites us to reflect on our own existence. Isn't it amazing to think that by looking at the sky, we are seeing fragments of our own being? The search for life on other planets is also closely linked to stardust. Scientists have begun to decipher the secrets held within this dust, searching for clues that could indicate the possibility of life beyond Earth. Every particle floating in the vast space may contain the key to understanding how the right conditions for life are formed. What mysteries will stardust reveal to us in other worlds? As we delve into this fascinating topic, we cannot ignore the impact that stardust has had on the history of the universe. From its role in the creation of galaxies to its influence on the formation of planetary systems, stardust has shaped the cosmos as we know it. Every corner of space is imbued with its essence, like a silent witness to the evolution of the universe. Cosmology, which studies the origin and evolution of the universe, is also enriched by the presence of stardust. This dust not only helps shape stars and planets, but also offers us clues about the expansion of the cosmos. It is like a cosmic map guiding us through history, revealing hidden secrets in the fabric of space and time. In a more cultural sense, stardust has inspired generations. From ancient mythologies to contemporary science fiction works, its presence has been interpreted in various ways. How has the idea of stardust influenced our worldview? The connection between humans and the cosmos is an inexhaustible source of inspiration, inviting us to explore and question. As we conclude this journey, it is vital to remember that stardust is not just a topic of scientific study, but also an invitation to reflection. It reminds us that we are all made of the same materials that form stars, and that each of us has a role to play in this vast universe. Isn't it a beautiful reminder of our own insignificance and greatness at the same time? The next time you step out to gaze at the stars, think about the journey those little points of light have taken. Think about the stardust that has traveled through time and space and how its story is intertwined with ours. In this cosmic journey, stardust is a thread that connects the past, present, and future, reminding us that we are part of something much larger. Thus, as we close this chapter, we reflect on the importance of stardust in our understanding of the universe. It is not only an essential component in the formation of matter, but also a symbol of connection and continuity. Every star, every planet, every living being is an echo of that stardust, a reminder that we are all in this vast cosmic adventure together. The next time you immerse yourself in the darkness of the night, remember that you are not alone. The universe is with you, and in every particle of stardust, there is a story waiting to be told.